Hello everyone and welcome back to Solidworks Sunday. Today I'd like to revisit the part from my last video because I want to show you the shell and draft commands. Since I mentioned shell first, I'll go ahead and talk about that one. This is in the Features tab, and it's a little bit left of center down at the bottom of the toolbar. And if you mouse over it, just like any other button, it will tell you exactly what it does. It hollows out a part, leaving open the faces you select and creating thin-walled features on the remaining faces. If you do not select a face, Shell creates a closed, hollow model. I'm going to go ahead and click that, and it opens up a dialog box just like every other button you can press. And it gives you several parameters. For instance, wall thickness. I'm going to put in 150 thousandths on this. Then it's asking for the face that you want to be open. And in this case, let's imagine that we were making an injection molded plastic cup or glass or some kind of metal tumbler. So I'm going to choose this top one, what will be our the rim of our glass. And I'm going to go ahead and also click the Show Preview button. And this is different. Most things just automatically show you a preview. And SolidWorks really likes to show you a preview of the geometry that you're about to create with the given parameters. You see it whenever you extrude something, or cut, or revolve, or sweep, or when you did the loft to make this part. And the fact that I am not seeing a preview right now tells me that something is wrong. It tells me that my day is about to get far worse than I wanted it to be. So I'm going to go ahead and click the green check mark and see if we get an error. And yes, we do. So the error says the thickness value is greater than the minimum radius of curvature. The shell may succeed, but you could cause undesirable results, such as bad geometry. To find the minimum radius of curvature, use Tools Evaluate Check. Okay, so I'm going to hit OK and see what happens. And yes, everything went straight to So I think since it's talking about the minimum radius of curvature, it's talking about these radii right here. What's happening is this is a relatively tight radius, and what you're doing with the shell command is offsetting inward from this wall. So what's happening is by the time it gets to 150 thousandths here, this radius is a sharp corner, or it like loops back on itself. So let's try changing that to say 50 thousandths and see what happens. Yeah, now we're getting ourselves a preview. And the problem is it's way too thin. It would probably work for a metal tumbler, but not for glass, or plastic would probably be okay too. That bottom looks pretty thin as well, and I'm going to take the opportunity to show you this. You can actually choose a second face here and do multiple thicknesses. So when I choose this face, I can specify a different wall thickness on the bottom from that face. So tell you what, let's say 0.375. Now in our preview, you can see we're going to have a nice thick bottom there, but the wall thickness here is still quite thin. So I'm going to go ahead and click the green check mark. It gives us our shell, and now I'm going to go back into our loft, and I'm going to change the radii on the corners of this hex so that we can get a little bit more wall thickness. So to edit that, I'm going to go to the drop-down menu, the little caret next to loft. I'm going to choose Sketch 1 since that's our hex. I'm going to edit the sketch, and I can just come in here and change that to, let's say, 250 thousandths. That'll soften up those corners quite a bit. And now let me exit the sketch and go back into my shell. We'll edit that feature. And now I should be able to plug in a thicker wall thickness. I wanted to do 150 thousandths to begin with. And yes, now it's showing us a preview that looks like it'll work pretty nicely. Because now when it offsets in from these corners on the hex, you can still see that we have a radius there. So now we have a really nice looking, relatively thick walled cup. And of course, I also said I wanted to show you draft, and you can find that in a couple of different places. You can find it in the features toolbar right here, just above shell actually. And you can also find it when you're doing your extrude. So let me show you that first. I'm going to go into the sketch command and click sketch. I'm going to choose the bottom face of this, this glass, because no glass has a completely flat bottom. It usually has a raised section in the middle. So I'm going to draw a circle here. And something like that. Let me smart dimension it to something in the neighborhood. I'll do 2.5 inches. Alright, and now when I go to features and extrude boss base, I'll get my dialog box, and you can see draft right here as well. First, let me go ahead and I'm going to make that a, let's say a 1/4 inch tall. Let's see what the preview looks like. Yeah, that's a little small, I think. Yeah, let's go a bit taller. There we go. And while we're in this view, I'll show you the draft. So I'm going to click the draft on and off, and it's got 5 degrees in there right now. So you can see there's our sketch that we drew. And if I zoom in, you can see there's definitely an angle to our part. Now, why does draft exist? Well, it's pretty much essential for any kind of mold or die or stamping work, because you need to have a little bit of clearance in the forming dies or the molds in order to eject the part. Draft gives you this little bit of taper that if this were an injection molded part, it would be able to pop it out of the mold relatively easy. And of course the inside of it would pop out very easily as well, because it's also tapered. That's just because of the shape of the part. I'm going to go ahead and click the green check mark, and yeah, that's starting to look like a glass. Of course, all the edges are really sharp. So let me go ahead and add some fillets here. I'm going to choose the fillet command. I'll go ahead and keep it at a 100 thousandths radius and see what that looks like. I'll choose that edge, and I also want to choose the top edge, but I think 100 thousandths will be a little too much. Tell you what, let's make it a 50 thousandths radius, and then I'll choose the top edges as well. Soften up those edges for your tender little lips. Alright, so yeah, now we have a nice round edge there, nice round edge there too, where it won't be a stress riser. We can also use draft inwards as well. So I'm going to draw a second circle on the bottom of this one. Relieve the center so the glass doesn't rock. So I will choose another circle. I'll come out to about right there. Let's smart dimension that. I think 2 inches. It probably seems a little excessive. Let's do 2.125. Yeah, that seems about right. Okay, I'm going to go into my features tab again. This time I'm going to do extrude cut, and I don't want it to be through. I want it to be blind, and I'm just going to go in 1/4 inch here, and I'm going to turn draft on as well. You can see the inner circle here is a little bit smaller than the outer one. The one that we sketched is bigger than this one in the preview. I think I want to add a little bit more to that. Let's make it 10 degrees. Yeah, you can see that that circle shifted. And we'll go ahead and cut that out. So now we have a taper on both ends. And I should go ahead and add a fillet to the inside of that as well. We'll keep it the same. And I'll go ahead and click my green check mark. Alright. We should probably be adding fillets to all of these edges as well, including the one on the inside, especially if this were to be made out of glass, because that would all be stress risers and lead to broken glasses pretty quickly. But I'm not actually going to make this, so I'm just going to come in here and go to Material, and I'm going to edit the material, and let's see what this would actually look like in glass. I'll close out all the steel, and right down here in other non-metals I can click that, and there's glass right there. Tells you a whole bunch of physical properties of the material right there. And I'm going to apply that, and then it changes the appearance as well. So now you can see through it just like you would if you were actually holding this glass. In this view, you can really see what these commands do. The shell's leaving this uniform wall thickness. Draft gives you the little bit of an angle there. You could pretty easily reproduce this shell effect using the loft commands that we used in the previous video, but this is basically a one-click button. It doesn't give you as much control, because if we were to come up here and use the lofted cut button instead, this is just a little bit left of where shell and draft are, we could actually have a lot of control over the shape of the inside. For instance, we could make the bottom round instead of hex. It's just a little bit more work, because you would have to redraw your geometry. You'd have to draw a circle for the top, another hex or a circle for the bottom. You'd have to add a little bit of reference geometry in order to get the thickness at the bottom as well. It would allow you to get something that's a completely different shape on the inside than it is on the outside, whereas the shell is really just going to offset inwards and reproduce a shell of the thing you already have. I've shown you creating draft in the cut extrude, but let's show it in the features tab. So right here I have another sample, and this would be a flywheel pattern, for instance. I want to do one other thing before I get started, and that is this little spoke here. I've shown linear and circular patterns in another video, but did you know you can click this, you can actually choose the entire completed boss and then run that around. So in this case I can go to my tree, I can go to boss extrude, I can go to my direction and click that face, or I could have clicked there, and right there you get a preview showing that you can get your 3 spokes. You can do 4 or 6 or however many, but this is a relatively small flywheel, so 3 is going to work just fine. If this were to actually be a pattern that you were putting into sand, you would need to have draft on all of these vertical surfaces to keep the sand from sticking to it and just destroying the mold as you pull the pattern out. You'll also notice that it's flat on the back, and that's because if you were making a sand mold of this, you would put this flat surface down on your table, you'd build your form around it or place your form around it, pour in your sand, pack it down, all that, and then flip it over and pull the pattern out in this direction here. So we need our draft going down from that flat surface outwards, so that when we pull this out, it will release from the mold. Likewise, if you were actually making this out of cast iron, you would need to have a second half of the pattern that aligns with this. So you'd want to put some pinholes in here so you can align the 2 halves. Of course, the purpose of this is not to actually make a casting, it's to show you how to make the pattern for a casting. Now let's get back to the subject here, which is the draft button in the feature tab. So again, feature tab here, draft there. When I click this, it opens up a dialog box. Surprise! The very first option is the number of degrees on the draft. I've got 10 degrees in here just so you can see it on camera, but if this were actually a casting pattern, it would be significantly less. The next box here is what's called the direction of pull, and you can click any face here. I'm going to choose this very top one, and you can see an arrow coming up there along with that note that says direction of pull. Next, it's looking for all the faces you want to add draft to. And in this case, you want every vertical surface. So I'm going to click this. I'll choose that inside face. I'll choose the face there. And then I'm going to choose each face of my spokes. And let's just make sure, yep, looks like I've got everything. And now when I click this, it's going to add 10 degrees of draft to every one of those faces. There we go. You'll recall that we chose the top face of this hub as our neutral plane. That's the face from which all of our draft is extending out, and the direction of pull was coming off the top. So it has added a significant amount of thickness down on this flat side, meaning that if you wanted to draw something for this pattern, you would draw this to your desired final dimensions. You would choose that as your neutral plane. Everything comes off of it and slopes down. Now this is a very extreme amount of draft, and in fact I can go in just like any other feature in the tree. I can edit this feature, and it got rid of our draft right there. So I can either choose new faces, I can choose a different neutral plane, but in this case I'm going to maybe change that to a more sane amount of draft, and there we go. That's a little bit better, 5 degrees. And if you look at it from the side, you can imagine this being a cast flywheel. Maybe you added a fair amount of extra material here, knowing that you would be machining this down to size once you've got a finished part. The last thing you would do if you were actually going to cast this would put some fillets on all these corners, and I don't know, let's try 0.125. You would want to put this basically any intersection between features, just to make sure that you had a little extra material there and you wouldn't get a stress riser. And lastly, I'm going to put a fillet at each edge. There we go. Let's see what that looks like. Yeah, that's not too bad. If I wanted to take off those edges, let me go ahead and click that, and way down at the bottom I can click that and delete it, and that one and delete it. I think I like the hub. Let's see what that looks like. Yeah, I don't know. I'll probably take off that last one in the hub as well. Now we've got fillets on all of our spokes. We've got plenty of excess material on here to account for both shrinkage of the casting as well as machining after the fact. And we've got a nice blank hub there where we can drill and bore a hole, maybe put a keyway and a set screw, who knows. I'm going to come over here to my tree, and about a third of the way down is material. I'm going to right click that and specify a material. I'm going to choose malleable cast iron. I would want to do that for a couple of reasons. For one thing, I might want to see how much this finished part is going to weigh after casting. Now of course this is only half of the pattern, so it's not going to give you the full picture, but it'll give you an idea. The other reason would be that Solidworks will give you volumetric measurements on these things, so you can see how much material you would need to actually fill this casting. The same thing goes for this cup model. If we wanted to actually mold this out of plastic or glass, you would want to have a good idea of how much material you actually needed to make sure you didn't have too little, and preferably have a little extra for things like the sprues and shrinkage and stuff like that. Hopefully you found this video helpful. If you did, hit those like and subscribe buttons down below. And if you'd like to help make these videos, please consider supporting me on Patreon or as a YouTube member. As always, if you have any questions about this or any other SolidWorks or machining topic, leave those down in the comments section below. Thanks for watching. I'll see you next time.